Good afternoon, everyone. Online guys are able to see my screen. Okay. All right. So yesterday we were talking about data types, and out of which dates are something which which had consumed a lot of time of ours. Any questions that you need to ask from yesterday's topics if you had gone through? Right? Okay. I hope you'll be able to practice more in the following week. We already have spoiled your Saturdays and Sundays. But I really need to appreciate you guys. Work the entire week, come on the weekends. I don't do that if I were you. One second. I do that, right? On every weekends. Okay. Yesterday we closed at diff time, right? Which finds out time difference. Yes? Any questions?
It's asking the same function. Actually, I didn't attempt it yesterday.
Okay. You can ask me that. So yes. Okay. So diff time, it calculates difference between two dates, and then you can specify which units you need to get the result. Do you want the time difference in, or do you want the date difference in days, months, weeks? By default it is days. Now let's close date data types with this one last functions from LubriDate. So of all the functions that LubriDate has, we have seen these MDY, DMY and all, which converts a string into a proper date format. Now once I have a date, like if I have date 1 for instance, so the class is of date type and its value is 2017 1st October. So you can use these functions like month, day, year and weekday, WDay. So you can use these functions to extract the date components out of it. So like we have seen that date or time is made up of various components, right? Year, month, day, weekday, hours, minutes, seconds. This is what component has, right? This is what a date and time component has. So I can use the functions as listed over here. I have a function called month, day, year, and I can extract the individual elements of it. So let's see this example. If I happen to print date 1, this is what you see on the console. If I run line number 270 and extract month, it gives me 10, the month number by default. This can also be extended by using this argument label is equals to true. So if I set label is equals to true, it will give me month name, right? To extend it even more, I have an argument called yes, date should be in date format. What do you say? The data type of that object should be a date type. No matter how it looks, it should be of date type. So I have one more argument called ABBR. So if I said ABBR is equals to false, then I'll get the full month name. Right? This is how month function works. Amit, I think you didn't get the essence of dates in R. When I say that a particular object is of date type, it will always be represented in this format. Year with century, month, followed by day. This is how R represents a date type. And the inputs to the 4 functions here should be a date object. This is all what you should be knowing. Yes, please.
When you just lubricate month, when I get the October date, so why all months are coming? Just because level T we are in.
Okay, this is something called factor. I'll explain that when we talk about factors. Yes.
How that date 1 is representing 2017 10 Japan?
You were there in yesterday's class?
Yeah.
So yesterday we had created this object, right? Date 1 we had created yesterday. Or date 1 is some object that exists in my global environment. I don't know what's confusing over here, but this is date 1, right? We had taken something called date char 1, which is a character format. We converted that into date using as.date and stored in date 1. Yes or no?
Yes.
Yesterday we have done this, right? Okay. Now similarly, I have a function called day. So 1st October, day is 1. Now I think day will also have this argument label. So if I set label is equals to true, no, label is not here for day. I'm so sorry. I'm so sorry. Day does not have any more arguments. The only argument to day function is the date object. Next, of course, I have here, which is 2017. And here also has no other arguments. Okay? Alright. And finally we have this function wday. So if I use wday like this, the one which you are seeing on the screen, it will give me the day number. Now if I use labels is equals to true argument to wday function, it will give me the weekday name. So it represents Sunday as 1, Monday as 2 and so on. Same thing which happened with month, right? January was 1, December was 12. So now why I am discussing this problem is, we have a small issue here. Same thing also exists in SAS as well. I don't know how you handle that over there. There are a few things which needs to be done in SAS. I don't know that properly. But in R, I would definitely explain you the problem. See, SAS and R, both of them have taken the base dates as 1960 and 1970 respectively, right? One second. ARR is for abbreviation Amit. So if I use that option, if I set that option to false, like for instance, if I run line number 273 here, wday is giving me SUN instead of Sunday. So if I use abbreviation is equals to false, then it will give me the full day name. That's the thing with the ABBR.
Do you use true in abbreviation?
True is by default set to true, right?
Yeah.
ABBR is by default set to true, right? Yeah. So it is giving me SUN.
SUN.
Yes.
Okay, it's by default.
By default, it is taking true for abbreviation.
And so one more thing.
Yes.
You have written lubricate
double colon. Yes. So
you have to define each and every time.
No, it's not required. The reason why I have written this like this is I just wanted to let you know that wday is from lubricate package.
Yeah.
So once you load a package, you no need to write it like this, package name double colon. It's not required every time actually.
First we need to define that and
not defined. Load a package. First load a package and you can just directly use those things. I have just used this so that you guys can understand that this particular function is from this particular package. see, all these date functions are available in the 7 standard packages. Duplicate is something extra that we are getting. That's it. Alright. Now, like I said, SAS and R have 1960, 1970 as a base date. Problem comes when we have to represent any date beyond that. So if I take a day like 1965, October 10th, SAS, it's no problem with SAS. It's fine because it starts in 1960. For R, it's a problem, right? How would it store it? So dates prior to 1970 in R are stored as a negative number, which is obvious by now, right? Because let's take 1970 as 0. As we proceed on, as the time goes on, we are on a positive line. But if we have to go to the past, 1970, it's minus. That's one thing. No, 1965 will not show as 2012 in R. I don't know who told you that. Let's try to find, or let's try to figure out how that is getting done. Let's take a date char. Let's say we call this date char 6. And I take a date somewhat like this. 01 October 1965, right? Now converting this into date is not a big deal again. So date 6 I'll call it. So date 6 this is as dot date char 6. Format would be %D %, yeah, capital or small? Fantastic. And capital Y, right? I run this. If I print date 6, so it gives me 1965 10/01, which is fine. And what if I convert this into number as dot numeric date 6? That would be a negative number because you're going back the line, right? So this is the first set of information that I have for dates beyond 1970, beyond 1st Jan 1970. Now, case number 2, special case, or let's rather say it, kind of an irritating case. What if I have a date char like this? If I call it date char 7, I'll have a date something like this. You know that you contain in your data set, you have, let's say, you are handling some bank's data and you have a customer's date of birth. And you know that there are customers who are born well before 1970, right? So you have that data set, but somehow your dates get represented in this format. Let's see. Let's say, again, let's take 10th October 1965. Instead of 1965, it puts it as 65. 10th OCT 65. Yeah, sure, I'll show the previous code. Here it is. And it's nothing, it's just converting a date, a character into a date. Alright, so let's take 1st October 1965, or yeah, 01 OCT 1965, like we did it in the previous example. Now how do we convert this into date? Let's try doing the method which we know. So I say as dot date date char 7 format is equals to %D, %B, small y. Or I can simply use, which function from LibriDate I can use for this? DMY. I can use DMY and get the same output. Okay. Now if I run this, There's a small problem here. Like I said, you know that your data contains date of births of your customers, for example, and you know that there are people who are born well before 1970 in a date of birth column. So now look at this. It says it is 2065 instead of 1965. Because obviously R will not understand it. R will take any date after 1970. This is a problem, right? Once you're getting data into R, this is a major problem, isn't it? How do you solve it? Any idea? Change the range? How?
We have in SAS that 100 years range is there.
R is not SAS. Any hint that you guys can give, or any guesses that you can make? We have seen 4 functions before coming to this section. Year cutoff change? No, Arjit, no. This is not SAS. We have to specify century. Yes, you can do that, but there is no designated way or designated argument to date function to do that. Anand, yes, it's a very good guess, but no, it's not the right answer. Can we change origin? No. Anand and Rohit? No.
We can separate
Exactly. This is what I was expecting. So we can use the year function, extract the date 7th year and subtract it by 100 years and then store it, right? We can do that, isn't it? Because we know that we have some data which is beyond 1970 but not beyond 1900. You don't have your banking data from a person born in 1865, right? You will not have it. So in this case, what we'll do, in this specific case, so see, the case which I am telling you is indeed a special case. It depends on the data that you are working with.
we have that data.
So it depends on the data that you are working with. Insurance, banking, usually you find these cases. Why just insurance, banking? Even in retail, when you are building your customer base, your customer date of births are well beyond 1970. At least they will be less than 1900. This is what we all know, right? So what we will do is date 7, we will extract out the year, right? So year of date 7 is 2065. If I subtract 100, it's 1965. Now, I have to save it back to year, right? So, please pay attention to line number 299. I will subtract 100 years from date 7's year and again send it back to date 7's year. Any doubts in this line? It's almost like doing A is equals to A minus B, right? A minus 100, isn't it? Any questions on this line 299 online, guys? So now if I print date 7, it's 1965, right? Isn't it? Yes, changing as Rohit and Anand suggested, we can change the base year. We can change the base year to 1960, but what if somebody is born in 1949? Again, it will be a problem, right? Yes, any question? Okay. Akanksha, yes, this can be applied on a whole column. If I have a column, I can apply this. See, any operations that I'm doing here, till now, whatever we have done, like data type conversions or fetching the data type, all these functions are very much applicable to everything in R, right? Why 100? See, why 100? Because, of course, man, like If I just want to go back to 1900s, I'll subtract it by 100 years, right? What happened when I used year in 1945? I didn't understand your question, Manoj. I didn't get your question, Manoj. You can turn on your mic and speak. So if the format is 12th October 1934, it's almost same as line number 288, 01 OCT 1965. It's a straightforward case. That's not an issue at all. Issue comes in when date is expressed without the century. Right? Yes, Mohammed. We are using 100 to get back to the previous century. How come the date output changed when new objects here, date 7? The date output changed because I am changing the properties of an object, right? Line number 299 is doing that. Date 7's year is being extracted and then 100 is being subtracted to it. But in DOB column, some are born in 60, some are born in 90. How will R understand? Huh? Again, I quite didn't get your question, Akanksha. So if someone is born in 90, then that's not a problem, right? Or is it?
Hello?
My question is, if someone is born
Hello?
when someone in 1990, so all of these in the same column. So if you subtract 100 from all of these, so 1990 would become 1890.
1890. Okay, that's what she's asking. Okay. So let's try and see what 90 gives me. I have changed date car 7 to 01 OCT 90. Okay, so then this would be a problem, right? So you can conditionally remove those things which are, see, what I said, it is a special cases which lie below 1970, right? So you can identify that, right? You can apply those logic. See, R is not SAS. The reason why I keep saying that is, SAS you have one function which can do all the tasks for you. You will have all the options in this world. One function can contain everything, but R is not like that. A process is to be broken in multiple steps. Perhaps one of the reasons why R is easier compared to SAS. So you know what is happening, you know, you can take control of it, like this case which we are discussing, right? Yes, we have to use some conditional and remove dates which are below 1970 and then apply this 100-year subtraction on those dates, right?
We can do looping here, right? By looping.
Loops, no, not loops. Loops, don't use the word loops.
No, then if suppose I have a database of a customer where the date of birth of a customer is like 1923, 1970, 1990, then if you'll apply the same code, year, date minus 100.
So what's the requirement of loop here?
Like if we apply the loop, then we can set that, say that the date of birth, if the customer's date of birth is beyond 60.
So that is called conditional, not loops, right?
Yeah, sorry, conditional.
Conditional is what you will be applying. Why loop? Okay. I think we can pretty much close the dates topic over here. Not just the date topics, but the entire data types can be entered here. If you get any questions, any issues on dates, you can post those questions on the forum. We can discuss that over there. I hardly see people using forums. Appreciate it. Really thankful that you are reducing our burden.
How about you create a WhatsApp group?
No, that's not allowed. They're illegal. I hate this notifications from Facebook, man, seriously. But in many cases of dates like 0 to 90, 0 to 45, 85 means 1885. So can we get exact years? If you're dealing with a data which contains 1885, I would really like to meet you, man, seriously. I don't know which data or which organization will still use data beyond 1900. Please let me know, Rohit. Now, those things are a little bit tricky. I won't say that it won't be possible, but it won't be possible in one single step. You have to apply logic. You have to write few more lines of code and segregate data beyond, like one set of data which is above 1970, one set which is below 1970 and above 1900, one set which is below 1900, the 1800s data. You have to write that code.
So can't we use regular expression to change the base?
No, I'm not talking about regex here. I won't be talking about regex. Yes, you can use, but let's not talk about regex. So which data you worked on, Rohit? Please let me know.
Someone is making a family tree.
They don't make it an R. It's the data of Book My Show. Okay, interesting. So like I said, the only solution to your problem is use multiple codes and use multiple logic and separate it out. That's the only thing. Okay. So person born in 1885 is booking a show in 2017. That's interesting actually. World is weird, man. Come on. Who said world is a boring place? Alright, moving on. Any more questions on date, please? Acha, the double colon, Amit, I told you repeatedly that I'm just using it for you guys to know it. Or else it's not required at all. The double colon method of invoking a function from a certain package. It's not required. But what's mandatory is that you should load the package. Like if you are trying to use some function from LibriDate, you must load it first in a session. I don't think so it will run. It won't run, I guess. If you're not using double colon, sorry, if you're trying to use double colon without loading, I guess it will not run. Thank you. Okay. Let's now get into data structures. What is the standard function taking date part of standard package? What? I didn't get your question, Amit. I didn't get your question, Amit. If you have anything to ask, I'll be just waiting for you. How to take out year from standard package? There's no package called standard package. Actually, the base packages, I guess, right? Okay. From base packages, we have something called POSIX. Portable Operating System Interface Exchange or something. POSIX. So POSIX can be used, but again, that's highly complicated. The same POSIX logic is being implemented by your LibriDate. If I'm supplying an object, it will convert into POSIX and it will extract. But only thing is, the best part is, you know that you have a function directly called year, instead of you taking that object, unlisting and doing all the stuff. So, yes, to a very large extent, R may make your life miserable, but why do you want to make it even further? So that's why we have packages to ease our work, right? Alright, let's get into data structures now. So till here we have answered one question, that is, if I have an object, what kind of information is being stored? Now let's see how that is getting stored. So if it's a table, if it's simple object, if it is an object with multiple values, how that is getting stored. So before going there, I just want to tell you a brief thing about the various information storage. So I can have an object called X, which will straightforward store one value. Right? This is what we have seen till now. I can have a variable called X, which will store multiple values, one object that can store n number of values. Where is that? Okay. So one object storing n number of values. This is what is my second case. Where is this? Now let's take one more case, X, the same case as above. This object storing multiple values, but not only in this manner, but not only in this row-wise manner, it will also store your column-wise data. So your data will also be spread across columns. This is one kind of storage. A little special case of X would be somewhat like this. An object storing multiple information in multiple dimensions. And not just that, it will also contain multiple types of information. So instead of just blue, it can have objects of any other type as well. So I can have the greens, multiple greens, multiple blues. So this can be one of the cases, right? And finally, we can have a super object which can act as a container that can store any of those objects. So super X can contain X. Okay, let's call these some names. I'll call this V. I'll call this M. I'll call this T. So there is a super object which can hold any of those objects, right? So this is the cases. These can be the possible structures of your data. Clear with this? Again, I'm repeating. I can have a simple object which can store one information in it. I can have an object called V which will store multiple information inside it. Wait, Amit. I can't be this, I can't be faster than this. You have to wait till I complete. I have one object which can store multiple information in multiple dimensions. And also I can have a special case of M which will store multiple information in multiple dimensions and multiple data types. You can see that, like different colors representing different data types. And I can have something called super object which can store multiple objects inside it, multiple such objects, multiple such data structures inside it. So this is what is the structure of your data. Till now we have discussed about the data, information of what contents we have. Now if we have contents, we have to put it in some bags, right? So these are the 5 cases of bags that we have in R. So let's discuss everything one by one in detail. Yes, super X can store multiple objects of any type. Basically, super X is a bag which contains other objects. So objects contain information, super X will contain objects. So let's see. So if I can just copy these information over there. this is what I was talking about. Data structures in R of two types, homogeneous and heterogeneous. So if I can just name this in the same color, which color I have used? Okay. So these cases, X, V and M, if you can notice, all the three, they contain the same data type. The data type is not changing across them, isn't it? So these things are called homogeneous data type. One information or multiple information of same data type. And then I have second category of things which are heterogeneous. Multiple information and multiple data types. So the orange thing here that you can see is what R technically calls them. X here is a simple object. It has no name. You just call it as an object. V, if you can notice, V is a vector in R. V is called vector, like one object holding multiple information, but of the same data type. Now, if the same objects hold multiple information in multiple dimensions, it's called a matrix. We have also one special case which practically is not used, so we won't be discussing it. There's also a concept of array, which is three-dimensional homogeneous structure. It's like a super object which holds a matrix, multiple matrices in various positions. So that object will have positions named like 1, 2, 3 till infinity, and each position can hold a matrix of the same size. So that's called an array, which we will just ignore it because practically it's not used anywhere. We'll stick to vector matrix. So any questions in first three? Simple object, vector and matrix. So you understood what this structure, how these structures look like. We are yet to see how do we implement it, but at least I hope you people get an idea on how these things look, right? Online guys, what about you people? I hope you get a faintest idea of how things look here. Now, just going forward, I have this thing called T here. Multiple objects, multiple information, two dimensions, and it will have multiple data types. This is analogous to your regular table that you have seen till now, right? Tables are two dimensions, tables have columns, and those variables or columns can have any number of data types, right? So in R, a general table in R is known as data frame. Any table in R, a table that you have known and seen till now, it's called a data frame in R. And then finally we have a list, which is the super object that I'm talking about. A list can contain other objects. Array will have matrix on same data type. Yes, Amit. Matrix itself means same data type, and array, if it has 5 positions and it is holding 5 matrices, all the 5 matrices should be of the same dimension and of same data type. It can't be a mix. So because it has to maintain the homogeneous nature, right? That's why. Now, when we just try to see them in R, we will see 4 things. How do we create those data structures? How do we access the elements? How do you apply some conditions to it? And then finally, we'll see some additional features. Super X or super object is called list in R. A list can be a placeholder or a container for other objects. So let's get into data structures now. Now, a simple object you have seen, right? X is equals to 10 is a object, simple object. So some of the functions that are associated with this also we have seen, like we can find out the class which gives me the data type of it, or you can just print its contents, right? There is also special kind of print statement called cat. There is a special print statement called cat. Like sometimes we keep doing this, right? Like, print something like this. The value in X is, and then you want to have that value. So that can be done using cat statement. This cannot be done using print statement. Why do you have to use cat? Because print can't do it. Now let's talk about vectors then.
Semicolon is required.
No, semicolons are not required in R. In first class.
No. I think the column.
No, comma is required.
Over there, X is.
Which one?
Is column
Is
The value in X
inside quotes.
Oh, that's inside quotes, man. Come on, you can put anything in the quotes. You can put anything over there, right? Okay. Now, vectors, we will, on very first level, let's try to see how do you create a vector. How do you create a data structure which can contain multiple information? So the very first way of creating a vector is using the C function, a combine function. Combine function will take multiple information and combine them to single units called vector. C function will take multiple information and combine them in form of a vector. Is the board clear to last people? It's clear, it's not blurred, I guess. It's not? That's fine then. Okay. Now let's see some examples. I'll take V1, use the C function, put some random numbers to it. So now it's done. Okay. How many elements? 10. Okay. Look at this for a change now. V1 is quite different from X, right? X was straightforward storing only one value. Now V1 is storing multiple values in it. This V1 here is called a vector in R. And because this is a homogeneous object that can hold only one value, the class, one type, I'm so sorry. The class of V1 will always be numeric, or the information that it is holding. It has all numbers, so it is numeric. Now, the way in which a vector manages to stay homogeneous is that it will perform automatic type conversions. Dynamic typing, yes. So, let's say I'm trying to create another vector called V2, the same way how I have created V1. Sorry. So, somewhere in the end, in the creation statement of it, I'm putting up a string inside it, a character inside it, right? So what will happen? This will not throw any error, but V2 will be entirely character type. So what it has done is, it has taken the values and converted those numbers into characters just to accommodate ABC over there. Because it cannot do anything with ABC, right? It cannot convert that to number. So it converted other numbers to character. So that is how it maintains its homogeneous nature. I hope you guys understood this.
What if we use the sum like A, B, C and last end with the number? We use strings and end with a number. Then what?
It would still be a number, a string, right?
Nobody is saying the same. A, B,
In
C,
a
1, 2,
single
3.
data type,
Uh-huh.
single data type, we use A, B, C
Uh-huh.
string and end.
That number will be converted to string, right?
Okay. Anyhow,
The entire thing should be of character type. Because character happens to have a higher precedence. Yesterday we had seen a table, right? Which can be converted into which, right? So, class of V2 would be character. If you use number within quotes, then if you use number within quotes, then it is obviously a string, right? Is it implicit conversion? Yes, of course it is implicit conversion. I'm not using any spells. It's happening itself. It can show integer also. No, it won't show integer, ma'am. Vectors of chars are possible. Yes, a character vector is also possible. Let's make a name vector. Name vector of all the online people who are more active compared to others. Who asked this question? Okay, Tanvi. This batch. This is active. You have Akanksha. Harish, yes. No, he's active today. I'm talking about last 3 classes. Amit, of course Amit, man. Come on. Amit. And Rohit, yes. He paid quite a lot of time today. So Rohit, so is Fanendra. And who else is more active these days? Sonam, yes. And she's more active. Manoj, yes. Be a bit mature, please. Apart from that, others, yeah, Arijat, yes. ARJIT, okay. I think that's enough. Yeah, apart from these people, others come occasionally, guest roles. So the reason why I'm doing this list is not to insult you, but just be active like these people, right? Now, you asked for a character vector, Tanvi. Here we go. So N1 is a character vector of 9 elements. And class of N1 is character. Now, second way of creating a vector is sequencing. So, of course, numbers and dates can be sequenced, right? Plus 25, plus 27, and minus 26. Okay. So if you do that, Rajshekhar, whenever you have plus, I think plus will give me an error. Let me do this. The plus is not giving an error. It will simply take it as 54. So if you're using minus sign in front of any number, then a negative number would be added, obviously. Plus is by default positive. If you are putting a unary operator minus sign, then it will add up a negative number. What if date? Yeah, Tanvi, I'll just tell that now. How do we handle date vector? So numbers and dates can be sequenced. So your first way of sequencing is using a colon operator. So look at this. If I say vector v2 is equals to 1 colon 10. So it will generate numbers from 1 to 10. That's a normal sequencing, arithmetic progression with increment by 1. Second case, I have the sequence function, which is more mature, which gives you more control. So colon operator can be used in various ways, like I can have 1 colon 10 or 10 colon 1 for the reverse sequence. But in any case, your increment is always by 1. Now I have sequence function, which will take, let's see the syntax of sequence function, which will take the origin and the destination, or the starting point and ending point, and it will have an argument called by is equals to. So by is the place where you specify the incrementation. If you say by is equals to 2, it increments by 2. 1 is default. So let's see some examples of sequence function. So I'll take a vector v3, or I'll just not take a vector, I'll just print the contents. If I'm not storing it in any objects, it won't be cached. It will not be saved if I'm not storing it in an object. It will be just printed on the console. So let's take another vector v3 and say sequence 1, 20. That's it. So v3 will be 1 to 20, straightforward. It's also almost equal to 1 colon 20, right? Let's take the another example, v4 for instance. I have sequence 1 to 20, by is equals to 2. By is equals to 2. Now v4 will have numbers from 1 to 20 but incremented by 2, right? The class of all these objects v1, v2, v3, v4 will be the it will be the data which it contains, right? It contains numbers, so the class will be numeric. v5 sequence, let's say I want numbers from 100 to 10 decremented by 10. So when you're going in a negative sequence, make sure that you're putting by as a negative number. So it has to be minus 10. Minus sign for decrement. So because 100 to 10 we are decrementing, right? So that's why I have to put a minus sign. Clear with this?
It can go till 0.
It can go till 0. Yes, it will. It can go beyond 0 as well. If I say minus 100, so 100 to minus 100, decrement by 10, right? I can have a sequence something like this. Let's say v6 sequence. The first argument that I am passing is called from. From is equals to 1. There is an argument called length dot out. If I say length dot out is 10, let's say 100, I'll say increment by 2. What do you mean by this? The meaning of this statement here is, yes, starts from 1, not darts, it starts. Like I said, I need a bigger keyboard, man. Starts from 1, increments every number by 2, gives a vector of size 100 specified by length dot out argument. Got it? Let's run this. So here is V6. Can decimal numbers be used like this? Yes, I want you to try it. But initially in first class we used 1 to 10, it showed us integer. Okay. I think colon operator will store integers, I guess. Okay. Colon operator is storing as integers. We have discussed that in the first class. By is mandatory, or we can write, yes, you can write it in that way, Ayush. Writing by is not mandatory, but thing is, like if you write stuff in SAS, it's always mandatory for you to use those argument names, right? Say proc import data file is equals to this, dbms is equals to CSV, for instance. Get names is equals to yes. If you just randomly write yes over there, SAS interpreter will not understand it, right? But it's not the case with R. So you don't have to write any of these statements here, but just think of it logically. If you're not writing the argument names, it will be always confusing, right? So if possible, write the argument names. So like I have done in line 351, I'm doing something which is different from the common syntax. So I have used the argument names. I've used an argument called format is equals to in as.date function. I can just skip writing format is equals to. It will still be correct. But again, like it's always good to write it, because the one who is reading the code, the one who will read your code, it will be good for them, right? So it's optional. It's good programming practice. That's it. All right. So that's sequencing way of creating vectors. Third way of creating vectors is sampling. I have told you, right, Amit? Length 100 means it gives the size of vector 100. Isn't it?
What does the size mean in this
Size
case? It's
means
out there 200.
The maximum possible length of the output vector. Total number of elements. That is called size of a vector, right?
I was thinking in terms of length. Okay, fine.
I told you in terms of length only, right?
So can you run that V6?
Oh, in SAS it was like 2 raised to power 8.
Yeah.
So that is kind of a length.
Okay.
Was that in big bracket, that 1, 19, 37?
Index numbers.
Index numbers.
Just index numbers. See, it ends at 35, which is 18th element. 19th is just that. Okay. Now let's do sampling. Sampling is a process by which you take a larger vector, take a large vector and extract elements randomly. Extract elements randomly out of it. So this is called sampling. So sampling is also a way in which vectors can be created. So if I say, if I take a vector called V7, for instance, which will have numbers from 1 to, let's say 5,000. I have numbers 1 to 5,000. I can go for 50,000. Why not? Has much numbers. Like this is 5 lakhs, right? Or 50 lakhs? 50 lakhs. So V7 is a vector containing numbers from 1 to 50 lakhs. I need 10 numbers out of it randomly. I need 10 numbers randomly. I need to pick 10 numbers randomly. So that's when I'll be using sample statement. So I'll call this as v7 underscore sample, for instance. Anyway, sampling is again a very huge topic that needs to be discussed as a part of your BA. So you'll be doing something called students t-test and z-test. It all it all depends on sampling. So we'll learn sampling mode, methods of sampling and all. So just for here, let's look at this function called sample. Logic is, the motive behind sample function is pass a bigger vector, extract randomly elements out of it. So the arguments to sample is x, which is the data which we are passing. Here the data is v7, right? So x is equals to v7. Size is number of elements that you need. I need 10 elements, so I'll just put it as 10. That's it. So we have one more option called replace, which is by default. Let me check the defaults of it, please. So replace is by default set to false. So I'll just set it to false again. So replace, what happens is that option will decide if a number that has already been picked up. Let's say out of 1 to 5 lakhs, they have picked the number 99 as one of the elements. Do you really need 99 to be picked again once more? So if you don't need it, you should set replace is equals to false. If you want 99 to be picked up again in some element, in some other case, then you have to set replace is equals to true. Got it? Right? Okay. So I will leave the replace to defaults. Again I repeat, replace is used to specify whether a number that has already been picked into the sample, do you want it to be picked again? Then set replace is equals to true. So okay, these are the two arguments that I can go ahead with. So if I run this statement and look at the output, so randomly it has extracted few numbers out of it. So this is also creating a vector, right? This is creating a vector from a larger vector randomly. And every time I run the sample statement, the outputs will be different, obviously, right? Every time I run this, I'll get different outputs. How do you set those outputs and all? We can discuss it during sample statement, sample concepts, sampling concepts. All right then.
So here, if we, as I say that if we use the replace false, then it will automatically take a different sample, right?
No, I didn't say that. So let's say you're picking up numbers and you have picked up numbers like on the first element is, let's say, 12.
Yeah.
Second element is 44. Third element is 55 and so on. If you want 44 to be picked up once more, let's say you want that the compiler should automatically pick up 44 again, then you'll be using replace is equals to true. Right? Yes. OTPs are actually not random, but yes, you can almost think of it like that. It's like rand between any numbers. Rand between is a function in SAS, right? Excel, I'm so sorry. Yes. "44" as a number, not as an observation. I never talked about observation. Like, all right. So that's it about creation of vectors. Now let's see how do we index a vector.
Can we have conditions in sampling?
Conditions as in?
Like using by over there.
By is not condition. By is actually incrementation.
Incrementing.
So why do you need incrementation in sampling? Sampling is itself random, right? So sampling is random samples.
So, sir, there are no more arguments to this sample.
Yes, X size, and there is something called probabilities argument, which again we can discuss it during the BA class. We don't want to pile on topics for today. So always use this mantra when you're sitting in initial classes. When you're trying to take the baby steps, when you're trying to crawl, don't try to fly. You're crawling, people. So let's try to index a vector. Now, if I just print a vector like this, like let's have print v2, for instance. So if you print v6 here, for instance, can you not observe things like 1, 19, 37, 55, 73, and 91? I said that they are index numbers, right? So this is 18th element here, 35, and 19th element is 37. So I have 19 over here. In which brackets? Square brackets. Of all the available brackets, they have used square brackets, right? So it has to mean something. They could have used curly brackets. They look cute. They haven't. They have used square brackets, right? So it has to mean something. So square brackets are used for indexing. Any data structure, extract any element, you need the square brackets. Sorry. So let's try to index V6. Okay, let's take a smaller vector and index it. Let's take V1 for instance. So if I need element number, this one, if I need to extract 33 here, what should I do? V1 of 2, right? 0, 1, 2. That will give 33, right? Or is it 3? 3 or 2? So, okay. Whoever strongly agrees that it is 2, yes. There are some people who would definitely agree to this. It's not their fault because we are accustomed to having numbers from 0, indexing starting from 0. But in our indexing always starts from 1. If you can look at this, it's all already on the console. So indexing starts from 1. So if I need to extract 33, I need to use V1 of 3. That will give me 33. This is how you index. So this is indexing one number. You can index multiple numbers. Let's say you need first 4 elements. How do you do that? What should be your index? 1 colon 4. That's it. You can apply further logic as well, right? You need first. You need all even position numbers from vector V1. Can anyone answer this? No? The question is, I want to extract elements which are present in even positions.
Start from it will 2 starts with an increment.
Increment by 2, right? So use which function? Sequence function. Yeah. Go on.
Sequence from 2 and by 2.
So sequence starts from 2 till let's say length of V1 is 10, right?
Yeah.
So 2 to 10 increment by 2. So if I happen to run only this statement here, let's see, I'm just selecting this statement only, the sequence statement, not the entire line. It means it is generating 2, 4, 6, 8, and 10. These are odd positions, right?
Yeah.
That's it. So you can just play around this, I guess, right? Did anyone say I can? Okay. Now, if someone asks you to extract numbers in 3rd, 4th, and 8th position, how would you do that? 3, 4, and 8.
3, 4, and 8.
Yes.
We just write by comma.
We just write by comma. 3, 4, 8. 3, 4, 8. No.
Combine function.
This is not correct.
Combine functions.
So how do we extract 3, 4, and 8? The combination of positions. We can use combine function, right? So here we go. That's it. So how do you identify length of vector? I'll come to that, Sahil. Don't worry. Like I said, follow a mantra. You're taking baby steps. Don't try to fly. You may lose your teeth. So that's simple indexing. Let's try to filter a vector. Let's try filtering on a vector. Filtering means applying some conditions. Now you have vector v1, which is combination of some numbers and all stuff. Now you want to filter a vector. Let's say you need to get all elements which are greater than 10 and less than 20, for instance. So let's begin with it. So if I say numbers greater than 10 in vector v1, numbers greater than 10 in vector v1. So if you say v1 greater than 10, if you do something like this, so what this will give? It will give all the numbers which are greater than 10, right? No. It will give a Boolean vector. So every number here is greater than 10, so it is giving true. Let's use some other thing. Let's say greater than 20. So v1 greater than 20. So 12 and 11 are the only two numbers which are not greater than 20. So you have false corresponding to it. Rest all are true. But we don't want this. We need to extract 12 and 11. So how do we do it? So the second rule for the day is, if I can pass position numbers to square brackets, like I did it in indexing, if square brackets can take in positions, square bracket can also take in the conditions as well. So please pay attention here to line number 382. V1 within square brackets. I'm just passing on the contents over here. V1 greater than 20. That's it. So now look at the result. I will get all the numbers which are greater than 20. Or if I say V1 less than 20, I'll get 12 and 11 which are less than 20. Any questions in this?
So we can run any query or condition.
Yes, any conditions can be applied. Any query can be applied. Let's say, somebody asks you if numbers are greater than 20. If numbers are greater than 20, then add 10 to those values. If numbers are greater than 20, then add 10 to those values. How do we get it done?
Simply add those three.
Simply add. How?
V1 square bracket V1 greater than 20 plus 10.
Let's try to break this in steps.
Like,
So always remember, R is a language where one line may not, I'm not saying it cannot, but may not get the things done. Let's break it. Let's see. Very good, Nilesh. Excellent. Let's see V1, the vector. If I add 10 to V1, if I just do this, line number 386 here, please notice, it will add 10 to each and every number without any discrimination. So this is one thing. Now, we need to perform this operation conditionally. Condition is the number should be greater than 20. So what if we do something like this? So how do we apply conditions? If I say V1 greater than 20, so this is my perfect, sorry, not, let's say if numbers are less than 20, add 10 to it. That makes more sense, right? I'm so sorry. So I'll check for condition V1 less than 20. Now this is where I'm getting numbers that are less than 20, to which I will be adding 10 according to my problem statement. Now perform this operation in 386 when it satisfied the conditions in line number 388. Right? I can combine these two steps just like by an assignment operator. So V1 less than 20, which means I'm getting 12 and 11. I need to add 12. I need to add 10 to this kind of a vector, right? So if you just want to break this into steps, let's try to save it in a vector first. We'll call it V1 LT for less than 20. So V1 LT 20, LT in less than. I'll just put it in caps so that it's less confusing, right? So this I have a subvector now which contains 12 and 11. So if I do an operation like this, so V1 less than 20 plus 10, right? So what it gives now? So 22 and 21 instead of 12 and 11, alright? Now,
What if you directly add, sir?
problem here is this is not doing in the main vector, right? I need to add this in the main vector. I don't want to create any subvector, so I'll just ignore this step. So you can simply get it done by this method. So V1 less than 20, it gives me 12 and 11. I'll just assign and add V1 plus 10. Will it give me a proper output? Will it give me a proper output? Let's try. So no, this is not a proper output. What is it?
uh,
32 is?
46 or after 40, the number is 11.
There is no number less than.
I didn't get it.
Make it less than 30.
Okay, let us go from the beginning again. If people are not able to get it, let's create V1 again, the original sequence, right? So these are the contents of V1, right? My motive is check for numbers that are less than 20, and if they are less than 20, add 10 to it. So I said if I keep adding 10 to each and every number, then this will be your resultant output. But I don't want this. I want a conditional addition, like the condition is V1 where V1 is less than 20, right? So to combine these two statements, what I've done is I have used an assignment operator. So on the left hand side, I will check whether the given number is less than 20 or not. If the condition is satisfied, then I will try to apply this statement here. This is how I have written this line. So let me run this. Yes, there will be a warning, which is fine. But if you look at the contents of V1, I guess numbers would be changed, right? It is changing arbitrarily. No, right? I am really not sure what is happening actually. Right? Alright then, we'll do one thing.
It's subtracting also.
Yeah, it's also subtracting. I am not sure what is happening here. Okay. Well, let's try and ignore this. Let's take a break for 15 minutes. Everyone is feeling sleepy, including me. So let's take a break of 15 minutes and come back and... V2, thank you. Acha, so before going to break, we were stuck in this problem, right? So this was not replacing values which are less than 20. So this question, this line here, there is a slight problem with this. So if I just talk about a number, for instance, a normal number. So if I have s, let's say s or x, for instance, x has 10 in it. If I want to add 10 to x, I just say x is equals to x plus 10. That's fine. We'll add 20. So if I want to save it, I have to save it as x is equals to x plus 10. So this will add 10 to x and it will save it. Right? Instead of x, now I have this entire vector v1 square brackets v1 less than 20. So this is my vector to which I want to add 10. Right? So this is not in form of, the previous statement, right? This is not in form of x is equals to x plus 10. So the only change that I have to make it is this. So I'll just copy the statement again. So this is the incorrect statement. So here it is. Now this perfectly matches this kind of a logic here. X is equals to x plus 10, right? Clear? Once I run that statement, if you look at the console, yes, it will search for numbers which are less than 20 and it will add 10 to it. This is search and modify. Any questions on this? Online people, any questions? Amit, I'm sure you are clear about the indexing part by now. I hope there is no more confusion regarding that. Ayush, yes, ideally it should show 22 and 21, the only two values. But thing is, here if you see, we are acting upon the entire vector, right? So that's why it is not just showing the two numbers, but it is operating on the two numbers as well as displaying the entire vector. So it is not the one which we are expecting, that we would be expecting only two numbers to be shown, but no, it won't happen because we are acting on the entire vector and printing it. Any further questions? Okay, this will also give the desired results, I guess. So let us try creating V1. Let's try and check what's wrong with this statement. I'll see, that's what. So Mohit suggested this kind of a statement here. So okay, so V1 less than 20 is 12 and 11, add 10 to it. So it is now 22 and 21. Now if I put 22 and 21 in V1, so what will happen is all the elements are overwritten and V1 will have now only 22 and 21. That's the problem there. I don't want to lose my data, right? So that's the reason why I have to go for the above mentioned method. Can filter be applied on character values? Yes, of course, filter can be applied on character values. So if I take the vector n1 for example, so let's say okay, where did we create n1? Just a second, guys. Okay, here we go. So let's say I make some typo over here. Let's say for Arijit, I just put one extra I. Right? This is not a correct spelling of his name. So you want to replace that. Like so, this should not be Arijit. Instead, it should be Arjit. Like the I should be removed. So what is your aim now? What is your target now? So your target would be search for the string Arijit, so which is an incorrect string. Okay, stop blushing, Arijit. Replace it with the correct spelling, right? So do this. All I have to do is in the vector n1, I should say n1 equal to Arijit, right? This is what it's doing is it will just extract Arijit out. So to this I will replace. Replace means just reassign something. So I'll use the assignment operator and I'll put the correct spelling over there. That's it. Clear? Any further questions on filtering and indexing of vectors?
Like if we want only names of the people which starts with A, can we do that?
You can do that also, but it requires again further logic. It's not straightforward. Nor there is a function that can do that for you. Can we try filtering people having 5 letters in this name? Yes, Mohammed, you can do that. Only thing is, you have to apply further logics to that. You need to extract each and every string, find out the length, and then replace, and then extract. So one statement cannot do that. You have to write multiple lines of code for that. Any other questions? Oh, Sonam, I explained that when we were talking about operators, right? The relational operators. So an equal to denotes equality. Don't confuse that with your SAS equality operator. Yeah, SAS, it would have been a straightforward equals to operator, right? Okay. All right. So now let us talk about some functions related to vectors that will be a little bit helpful for us. So I will just be talking about generic, like it can be any kind of vector, or some function that we'll talk about would be specific to numeric vectors. So let's see it. First function is length. So length function returns the size of the vector, or number of elements in the vector. So V1 has 10 elements, so I'll get 10 as an output. So if you look at an example here, previous example which we had done, in indexing V1 where you're extracting all elements. So we had indexed, right? Extract all elements from even positions. So we had written this code, right? V1 within square brackets, sequence 2 to 10 by 2. 10 we knew it because we have seen it on the global environment that V1 has 10 elements. How do you write this programmatically? How do you want this control programmatically? Instead of 10, I'll just put length of V1. So it means by is equals to 2 till length of V1. Sorry, from is equals to 2 till length of V1 increment by 2. That's it. It will give the answer. So had 10 not been the end number, let's say you added few more elements to V1 afterwards, and 10 is not the final number, you don't know that. So length is a safe side, right? Length will give you length of the vector at any given point of time. I hope you understood why I have made a change to this, right? So that's about length. Again, if I take a numeric vector, I have certain functions like min, max, range, so for a numeric vector I have mean, sum, median, and so on. You can think of n number of functions for these, which anyways you will come across during the second BA class when we try to find out univariate analysis for a particular variable. We can anyways come across these functions again. So these are some functions which are quite familiar to or quite particular to your numeric vectors. Now, two more generic functions. One is sort. Sort is simply sorting a vector. So if I say sort V1, so it will arrange V1 in ascending order by default. Or if you say sort V1, comma, decreasing is equals to true, sort V1 decreasing is equals to true, it will sort it by descending order. Same sort function can also be used for character vectors. So by default it is alphabetic order. If you say decreasing is equals to true, it becomes the reverse order. No, there is no function for search as such. You can use the square bracket notations and find it out. But for advanced string search using regex or using any pattern search, you have a grep family of functions. But that's not. Let's not discuss that now. It's a highly advanced topic. So if you're aware of grep, then you have a family of grep functions, grep, grepl, gsub, gsubfn, and so on, which are used for string pattern matching. And that it's only for people who know regex. So even when you ask, like, when we can we extract people with names starting with A? Yes, you can do that using regex in a simpler form. Or you have to write certain lines of code. You have to think of the logic and write the code and get the output. That's a simple sort statement there. I have one more function called order. So let's try and apply that on. Okay, let's do this. This is n1. Order of n1 is giving me some numeric vector, right? Isn't it? Sort is giving me straightforward the sorted results. So what do you mean by order? Just look at it for a few minutes. Just look at my console and its output for a few minutes, and can anyone guess what is the function of what is the output of order function from the given two vectors? Index positions in random order? I don't think so, sir.
So positions on the basis of the sorting alphabetical order.
Positions on the basis of?
The sorting order alphabetical order that we have sorted.
Okay. Anyone from the online? Can you deduce what is the vector What is the output of order function? Position on ascending level. Yes, both of you have almost given the same explanation. Anyone else who wants to answer? Tell the position. Okay. Okay. Let's look at it this way. Let's begin with the sorted array first. I have sorted my array. I have Akanksha in the first positions because of the alphabetic order. Right? So what was the position of Akanksha in the original vector? Second, right? So here we go. We have second here. Next up, we have Amit. So what was the position of Amit in the original vector? Fourth. We have 4 here. Arijat, last number, the 9th position. So I have 9. Haris, it was in 3rd position. So we have 3. Manoj, 8th. Yes, 8th position. So we have 8 here and so on. Got it? What order is? Order tells me that if I have a array which is a result of sorting of a previous array, then order function will give me the position from the original array. So order.
So do we need to use sorting before using the order?
No, I'm not sorting it, right? I'm just supplying order function. That's it. Did I sort it? I didn't sort anyone, right? I just supplied order function. So order gives position from the original array. That got sorted now. That got sorted. Sorry, original vector. Now I have one more interesting thing called a rank.
So sir, what is the use of order?
I'll tell you that. I have something called a rank now. What is rank?
Rank.
Number of occurrences of each.
Providing a position on the basis of certain.
On the basis of length.
Nope. So see, again, let us repeat order. Order considers the sorted array and gives the position of the elements from the original vector that got sorted, right? Now, rank will consider
Sorted one is the base one.
the original array, gives position from the sorted array. It's the opposite. So look at it. So let's consider Akanksha here. So rank 9. Okay. Let's consider Tanvi here. Now, this is my original array. So N1 happens to be my original array. Now, if I sort it, where does the this element name called Tanvi go? It goes to the 9th position, right? So position from the sorted array. Position of Tanvi in the sorted array is 9. So that is the rank. Or simply put, rank is just ranking the elements. Like once I sort the array, once I start sorting the array, if I just rank them and just populate it in the original vector, that is what is rank is. A rank has no practical use at all. A rank may or may not have practical use. It's just that it reduces your time. Like instead of you applying any kind of relational operators or something, instead of you sorting it and then finding out positions, you can simply use rank function. But order is little bit useful when it comes to data frames. or when it comes to the square bracket notation, to be more honest. I'll explain that. So if order function is giving you some positions, let's try to leverage that within the square bracket notation. So let's see it. So if I say order of n1, sorry, yes, I do need a bigger keyboard. So order of n1 gives me some positions. So let me pass it to the square bracket notations for n1. So if I say n1 within square brackets, order of n1, isn't it exactly similar to my sort function? Clear, right? So this is what is the advantage of order, because sort can be used only on vectors, whereas this logic can be applied to other data structures as well. So I will not use sort function at any other place. I will rather depend upon order function. Clear? I hope you understand now why. Right? Any questions, online people?
When we do sorting, the original places changes in the index, or we have to save it to a vector, that then only it would change the position.
Amit, once more. I couldn't get your question. Can you please repeat?
Yeah, but once we do the sorting,
Okay.
does the position change in the vector itself, or it is just for the display part?
Acha. As of now, in line number 437, if I just run the statement, it's just displaying. The things will change only if I assign it back to n1. Until unless I won't do it,
Okay, fine.
none of the statements will be changing the original composition of those vectors.
It is only for the display. Okay,
It's only for
fine.
display, yes. So again, everyone has to be more cautious when doing these kind of operations. So you see that you have run sort function and you have seen the correct output on the console, you're getting it. Please don't assume that you have made the necessary changes. No. Changes won't be made until unless you save it. Right? Okay. Now, there are also many number of functions available to this. So because today will be the end of your third class, I will be sharing one file with you along with the class file. So I'll be sharing this yesterday's and today's class to you, as well as the one more file which has a lot of other functions for you to practice. So I wish, I just hope you have 1 week with you till the next class. I hope you would give a good shot to all those things. Okay, right? So this will be uploaded either by today evening, most probably, or I'm 100% sure that it will be uploaded by tomorrow morning. Okay. Let's talk about matrices. Now, what I will do is, I'll not discuss much detail. So matrix is a thing, like it is a two-dimensional structure. So it's two-dimensional homogeneous. Two-dimensional homogeneous structure. Or let's say it is just a table containing same type of elements. So to create a matrix, I have a function straightforward called matrix. Right? And note this function will not stop those bullets like it did in the movie, right? This will just create a vector. So matrix function will take vector as input, take vector as an input. It will also take rows and columns as input, or row number of rows, yes, number of rows and number of columns as input, and it will populate every element of vector as rows and columns. It will populate every element of vector as rows and columns. Alright, so let's see how matrix function works. So I'll take an arbitrary object called my matrix. I'll use this matrix function, and let's pass on V1. V1 has 10 elements, right? Tell me one more vector which we have, V6, oh no. V5 length. Okay, let's pass V5. Let's pass the vector V5. So matrix will take a vector as an input. And if I just run this statement as it is, without any options and all, I'm just running the statement. Look at it in the data part. In the data part, it has created my matrix. Till now, all the vectors are being created in values part. Now, in the data part, my matrix has been created. So let's see. So if I just print my matrix, we just happen to print it. So it will give me all the elements of V5 arranged in rows and columns. Yes, it is being arranged in rows and columns. One row, 21. Seriously, 21 rows and one column. Wake up, classroom guys. So it's one column and 21 rows. So it has divided my vector into rows and columns. Clear? Any questions so far? Okay. Now let's further improvise this. I'll just call it as my matrix 1, for instance, and call the previous one as my matrix 0. Here we go. V5 is a vector from 100 to minus 100, decremented by 10. This one we had created using sequence function. Now, matrix V5 now have options: n row, n col, right? We have these two options. So 21 elements, again, the thumb rule for these matrices is that let's pass number of rows and number of columns as a multiple of these numbers. So because whatever I'm going to pass, if I just happen to multiply them, that will be the length of the, or that will be the number of elements that the matrix can hold, right? So there are 21 elements. 21 can be 3 into 7. 3 into 7. That's it, right? Yeah, 3 into 7. 3. Let's say 3 columns and 7 rows. So n row is equals to 7. N col is equals to 3. So we just happen to do this. It creates my matrix 1. It's just populating the elements here. It begins with 100. So V5 is 100 to minus 100 row wise, right? So now it starts populating it like this by columns. It will begin at this position here. First position, 100 has gone, and everything goes by columns. right? Till it reaches till it exhausts all the elements minus 100. So here is the place where it stops, right? Any questions in this? Any questions, online people? Why is it descending? It is descending because V5 is present in that way, right? So if you happen to look at the contents of V5, it is this. So again, like I said, V5 contains numbers from 1 to 100, sorry, 100 to minus 100 in descending order like this. It is just populating these in forms of rows and columns. I have 3 rows and I have 3 columns and every column will get these numbers. So first element of V5 is 100, it goes here. Second element of V5 is 90, it goes in to second row, first column. Third element is 80, it goes to first column, third row, right? Till it reaches to the end point. Yes or no? Any questions in this?
What if we write the n call equals to 4?
I'll tell that. I'll just tell that. But I hope, what do we want? Ayush, no, I won't be discussing that now. Again, like I said, when you're trying to crawl, don't try to fly, please. You'll lose your teeth. So, did you understand this thing? What is happening in this line number 452? Yes? Okay. Let's move on. Now, this is happening because we have taken perfect multiples, 21, because 7 and 3, 7 rows, 3 columns are perfect multiples of 21. What if we take something which is not a perfect multiple of 21? So let's consider one more vector for a change. Let's consider the numeric vector n1, which contains 9 elements. So 9 is 3 cross 3, yes, straightforward 3 cross 3. Now let's do that 3 cross 3 example first. I'll say my matrix 2, matrix n1, n row is equals to 3, n col is equals to 3. So here are the contents of my matrix 2. Clear with this? So the row wise data gets populated into rows and columns. 3 rows, 3 columns. It begins with first row, first element. In other words, it begins with first column and populates all the rows. It stops there till it gets exhausted. Then it begins with second column, populates all the rows till it gets exhausted, and so on. Now, let's do a very different case on this. What if I give something which is not multiples? What if my matrix 2 had been something else? I'll call this my matrix 3. Instead of giving 3 cross 3, I'll give it 4 cross 4 or 4 cross 5. If you know. So 4 cross 5 is 20. Implies the matrix can hold 20 elements. Clear until this? Any doubts, any questions? Online people? Okay. Now, let me run this statement, my matrix 3. Yes, it has given warnings, but as a good software engineer, you should always ignore warnings. Yes. So, my matrix 3, look at this.
Okay, it will repeat it.
So, repetition has happened, right? Yes or no? things have repeated. So logic is one and the same. I begin with first column. I keep on populating till I exhaust my number of rows. My number of rows are 4. So first 4 elements of my vector n1 get populated, which is fine. Right? Then it begins with second column. N1 has 9 elements, right? So next 4 also gets populated. Perfect. It will come to third column now. Now my entire vector ends over here. So if I can choose the color, that would be great. Okay. So my thing ends over here. Now once it has ended, but the matrix has not ended anymore, right? It can still hold many more elements. So what it will do, it will start repeating the elements. So first 9 came in, again it will begin inserting column wise till it gets exhausted here, it gets exhausted over here, and then I'll have 2 more values. So 9 plus 9, 18 plus 2, 20. So values get repeated. It won't put it as missing. It will not put as missing. It will just repeat the values. That's why I said matrix has no practical usage at all. It's just, populate your data as a part of rows or columns. That's the only use. And sometimes some functions may take matrix as an argument. So whenever we encounter that function, it means we are taking some homogeneous set of columns. We will let you know at that time. So all you have to know is how to create a matrix. That's it. Which you do now, right? By using matrix function. Any questions? Any questions, online people? One last example we'll do on this. I will call this as matrix 4. Till now what we had seen is we had taken a matrix and I have columns, right? And the filling was being done by columns. So we started filling by columns, right? So we have an option to reverse it. So we have an argument called by row. So if I said by row is equals to true, the filling will begin from row wise. So look at the difference between, just a second, my matrix 2 and my matrix 4. There's a difference, right? The first 3 elements, Tanvi, Akanksha and Haris, in the first example, my matrix 2, they got filled column wise. Yes. In second, no, that's not transpose. That's not a transpose. In second case, they're getting filled row wise here like this, right? That's the difference. No, this is not a transpose. No, this is not a transpose. This is not a transpose. How is this a transpose? No. Transpose of, okay. This is my matrix 2. This is the transpose of my matrix 2. But fine, like this is a square matrix, so it looks like a transpose, but no. This is not a transpose, this is a different thing. There is a difference between transpose and by row is equals to true. Never confuse that with transpose. Transpose is a different thing.
No, I was just saying for practice.
With square matrix we can consider.
Acha, don't do that. See, transpose is if I have like this, a case like my matrix 3 here, a transpose means we're converting rows into columns. So a 4 cross 5 matrix becomes 5 cross 4. But if I said by row is equals to true in this, it would happen, right? So this is not a transpose. for God's sake. It still remains as 4 rows and 5 columns. Any questions so far? I hope by row is equals to true has not confused you. The filling of matrix was being done column wise. If you said by row is equals to true, your filling will start from row wise. That's the thing.
So what if the space is not enough to hold the vector?
Right.
Like there are 9 elements in a vector.
In that case, again, it will throw a warning and it will ignore the rest of the elements.
So no error.
No error. It will just drop the extra elements. So that's why you have to, like, if you're explicitly creating a matrix from a vector, be careful that you are passing on a perfect multiple. If not, I mean, like if it's a prime number, then it's a different case, but ensure that you are passing a good multiple. Thing is, like if you have 11 elements in a vector, just make sure you're passing 12, 4 cross 3. One element may be extra, but that's not an issue. You don't want to drop one element, right? It's all about matrix. Let's spend a few time in getting into the main part of your analytics learning. And what is it? Data. Yes. This is the thing which everyone was waiting for. Like, how do I import my Excel sheets? How do I try my SAS assignments in R? How to get it done? Yeah? Hopefully it should be. Let's talk importing then. We'll do one thing. Before we start, we go for importing. Alright then, we're done with data importing. Okay. Online guys, are we all back? Are you able to see my screen? I'm actually getting learn R codes easily. Yeah, that's true actually. R codes are easier to know and learn. Okay. Let's write SAS code for a change, for a while, right? So here we go. I hope you people are able to see the font. I don't know how to change the font here. But just concentrate on this statement here. This is your regular proc import statement, right? Your options, your inputs here are data file, the path of the file that you're supplying. You have something called out. Out is something, specifies where your output should go. Library name dot table name. This is identifying the type of the file. Get names is an option which means the headings. Yeah, the first row of a CSV will go as column names. That's it, right? This is the basic import option, right? So R will also have a very similar syntax. Let's see how it is done. So in R, the function to read any text file. So let's begin with text CSV. So I have different function or different category of files. You had proc import which can import Excel and CSV, right? We'll have different function for different files here. So let's begin with text CSV. For text and CSV files, I have read.table. It's a generic data import statement, read.table. So which has all the standard arguments that a proc import has. So my first argument is file or file path, yes. So I will be passing the same CSV file as an argument here. right? There is a small difference. There is a small change that we have to make to this. That is, okay, this small change that we have to make this, because by default I am at my documents. I don't have to write the entire path, because by default I will be at my documents, and datasets is a folder present in my documents folder. So I can simply put datasets, because I'll anyways be pointing to my documents always. Now, there's a small change that you have to make to this file path here. If you remember University Edition, which is a Linux-based machine, so your folder path should be something like this, right? Yeah, I know it. I'm the one who handles those installation issues. So, okay. So this is the one, right? You will be having a forward slash, right? Linux style of slash. So in R, you have to use a forward slash. That piece of information you must always remember. In SAS, it is anything. You can use forward, backward, up, down, anything. It works. In R, it has to be always forward slash, or you can use a double backslash. You can use a double backslash like this. Sorry. You can use a double backslash. So that's it. Read.table. I have supplied the file name. Fantastic. I have an option called header is equals to, which I will set it to true. This is equivalent to your get names. Header is equals to true is equivalent to your get names. Now, the third option is SEP for separator. So, tell me, if I am importing a CSV, what is the separator there? Comma, right? So, in separator argument, I will pass comma as an input. That's it. That's pretty much it. It should import data, but one thing is missing here. That is out. So how do I do that in R? Assign it to an object, right? That's how I can store my output, right? So I'll call it stores. I'll call this object name as stores. So stores is equals to read.table stores.csv. That's it. Here we have in my global environment data part, I'll be having stores, right? A data set has been imported into the system. Now specifically for CSV files, we have read.csv. This is specific to CSV files, of course, right? You can't read any other statement here. So to read.csv, everything will be common, except that you don't have to mention the separator argument. That will not work, right? So I can use either of those, read.csv, which I frequently use because read.csv is much convenient. Not only that, it doesn't require separator. The separator is equals to comma is not required in read.csv. Also, header is equals to true is not required as well. It's by default set to true. Sridevi, I'm discussing about text CSV files. Next stage we can discuss Excel files. And Excel files don't have separators, right? So text files are either comma separated, tab separated, or they're pipe separated. Yes, they can be split by any character. So in that case, we can use read.table because it has separator argument. Clear with this? Any question? Okay. Next is Excel. Yeah, that's a very good question, Akanksha. Let's discuss this when we will be trying to export files. I'll talk about this, whether or not the objects here remain permanent or they are not permanent. What happens in SAS? If I have a library, so in my libraries, next time I open this, UVA, this is a custom library, UVA, Univariate Analysis. So that library would be gone, right? But once you run this libname statement, everything comes back. I can see these 3 data sets again after the session is done. Let's see what happens in R, but not in this stage. When we are exporting the data, we can see it, how R will be handling that. Fine. So as of now, no, this is not session specific. This is permanent. Whatever you are importing is indeed permanent. If you have to give the entire path, correct? Yes, if your files are not being stored in My Documents, let's say your files are in D drive. Let's say you are working on a university edition where you have created the folders in D drive, D SAS University Edition and stuff. So you can clearly link the files over here. You have to mention the entire file path. Are these commands mandatory in read.table, like header is equals to true? Yes, Ayush. Header is equals to true, separator is equals to comma is mandatory in read.table, but not in read.csv, because separator is not required as it is meant only for CSV. Header is equals to true is not required as well because it is by default set to true. Now let's talk about Excel files. Now, one of the most surprising things about R is that the base R cannot handle Excel files. Of course it won't, right? It belongs to an open source environment. None of these languages, they handle Excel files. You need some package to be installed. Even in Java, you have to install some jar files for that. Python uses a separate library for it. R will have a separate package for that. So what comes bundled with RStudio? RStudio comes bundled with Excel importing facilities. So by default nowadays, I mean, like since the recent update of RStudio, you have a very good package called Read Excel. Read Excel. This is a very beautiful package to read Excel sheets. So Read Excel has a function. So if I just put it like this, Read Excel has a very good function called read_Excel. Clear? And this will be helpful for us to install or import an Excel sheet. So let's see, if I just open my datasets folder present in My Documents, I do have some Excel worksheets. I have a file called auto insurance. I'll just copy that. It's autoinsurance.xlx. Yeah. So I'll just copy it to path. Don't ask me how I got that. It's magic. Now, in this, I should be mentioning sheet number or sheet index. So, to do both the things, my argument is sheet is equals to. Here I can simply say sheet is equals to 1, which is of course by default. So, if I can look at auto insurance Excel sheet, it has 2 sheets, auto BI and auto claims. It's an insurance data set, by the way. So, if I want to extract auto BI, I can simply pass it as sheet number. Sheet is equals to 1, or I can mention the sheet name if I know. I can call it AUTOBI. I should ensure that the spelling is correct. So I should pass on the sheet name, or I can simply pass the sheet index. Both will do. So that's it. If I run the statement now, yes, we are missing one thing. We should assign that to an object, right? So I'll just call it auto insurance or auto INS is equals to read underscore Excel paths and sheet. That's it. Okay. That's still 12 warning, so it's fine. So this is the contents of Excel sheet from our Excel workbook. Clear? Now if you have 10 different sheets, you have to write 10 different read Excel statements, of course. Any questions so far?
So what if when we import Excel file, it says what does it, if there is a missing value, it will show as a dollar.
I'll talk about missing values later on.
Okay.
I'll not talk about missing values now. Get names and all is not required because they are automatically handled. Tanvi, I would agree to disagree. I would disagree to agree on that statement. Not all the things in R is session based. Is there any possibility of truncate in R? Truncate as in Rohit? Acha. Again, reminding you guys of all the things again. No, I cannot use multiple options in this statement. No, I can't do that. You have to import your data once, then apply any kind of conditions that you want to apply. Shrunk your white space, remove your white spaces, do any kind of actions. Everything can be done. Read only first 10 rows. You can't do that in one single statement. You have to follow multiple steps for that. But your first step would be reading the table. In SAS, I have an option called skip rows, for instance. Like I can skip first 10 rows, right? It can be done, but the ideal way is just get the data into the R global environment first and then do any kind of action you want to do. Clear? No, Amit, AutoINS is not a temporary object for this session. Of course, Excel sheet names are always case sensitive. You should notice that in SAS as well, right? It's not a new question to ask. So this importing I can access in next session with the same object name. Yes, of course, Tanvi. You can access it. I will explain that when we are exporting objects. But as of today, please remember, like because next 1 week you're going to spend some time on these things. If you're closing a session, notice there comes a message. Save workspace to .r data. You must click save. Please. Thank you. So then it will be session. That will not be session specific. It will be across the sessions. Clear, Tanvi and Amit? No, Amit, it doesn't take memory space. Be generous, man. Come on. What's your RAM size? It would be good 4 GB, right? Can't you give few KBs to R? 8. So that's fine. Now, Amit's concern is also legitimate because the cycles consumed by R is more. It will take up more cycles. What happened? Okay, that was about Excel sheets. What else we can import? Oh yes, you have a lot of SAS7 BDATs lying around, right? Because all you have, dedicated your time on SAS, right? So how to read SAS7 BDAT? So you have a package for this. So every time I write require, if that package is not there in your system, don't ask me. You don't need my permission. Just install those packages, please. So I have a package called SAS7 BDAT. In it, I have a function read.sas7 BDAT. So again, in my datasets folder, I do have certain SAS7 BDAT files, and that is over here. I have something called stores.sas7bdat. Same arguments, just supply the file name, that's it. It shall read sas7bdat files. So I'll just call it in stores underscore sas. I'll just put that in objects. Load this package sas7bdat and run the statement. That's it. So I'll get a file called stores underscore sas. So this is basically the SAS file that I had imported here, because my path is set to the same folder, documents, dataset, stores.csv, right? So that's why I have stores.sas7bdat. So likewise, like if you have any SAS7bdat, just put it in a folder. Like let's say you're working on SAS examples, so we'll just use that in R as well. Get them to R. Try solving those questions. What other files we can think about in importing? Come on, go on. Text files can be done using read.table. How many of you have worked with XML files? No, none. Online people, has anyone worked with XML sheets? Okay. All right. Okay. So I'll just show you an example of an XML file. You must be knowing what is HTML, right? Your basic web page. So you have tags in HTML which are predefined. You have to follow those tags like head, body, and so on. So you have to follow those things. XML files are those in which you can give your custom tags, which custom tags can be given. So like for example, I have a data for a device, a certain network device, in which I have a tag called ID, in which the device ID goes in. I have some context where some random text has gone in. I have a timestamp here. I have some other text field here, and I have some error field over here. So these all are represented using tags. So these are the basic composition of a HTML file. Sorry, XML sheet. So if you happen to, we had done one of a project with one of the biggest networking companies in this world. I can't name it. So in which we were supposed to perform certain pattern recognition and monitoring over real time onto the network devices in 3 different layers. You have layers. You have 7 layers of OSI, right? Engineers, you can know it. So in 3 of the layers, we were supposed to put up some algorithm over there. So this is a sample data from those. So those devices, those network devices, usually contain XML files. Number 1. Number 2, your credit card machines. If I happen to import the data from the credit card machines, it will be in XML format. So that time you might need to convert an XML data into a data frame in R. So to do that, nothing complicated as it looks. It's nothing complicated as it looks. I have a package called XML, and I have a straightforward function called XML to data frame from XML package. Same thing, just take the file. Where is the file? So just take this file and put file is equals to, what is the argument? Doc is equals to, document is equals to this. The file name. That's it. So if I happen to run this, so I'll just put it in a object. So this gives me a data frame from the XML sheet. So look at it, ID number 1122, 1123 and all. They're different tags. So this forms one row of my table. Line numbers 3 to 9. So is line numbers 11 to 17. This forms my second row and gets populated as a data frame. I don't have to do anything. I just have to make a call. That's it. Now, this is a little bit interesting. This, how to connect to a DBMS. Sahil, come on, wait, man. Wait for it. Have some patience. You don't get it in the market, but you should have patience. Connect to a database management system. What I'll do is, because I don't have access to any of those high-end DBMS, hum garib log hain, so I have MySQL. I'll show that connections in MySQL. I don't have Oracle or SQL Server, so I'll just show it in MySQL. So what I have here is, I have a Apache MySQL PHP bundle. So I'll just begin my web server here. It's just simple, like if you just want to try out these steps, you can install XAMPP. Mac users, you have MAMP, M-A-M-P. And Linux users are geek enough to know this, so I don't have to tell them. But still, they have something called LAMP. So once I have this XAMPP, my web server and my DBMS are up and running. So I can just open my browser and access my database. So it's localhost php myadmin. That should lead me to the database. That should log me into the database. Yes, it did. I'll just freeze my screen for a second because I don't want to reveal certain sensitive information. Please bear with me. There are a lot of sensitive information there. Come on. Just bear with me for 5 more minutes, please. I hope online guys are able to see my screen. Okay. Look at this. Look at this. So MySQL works on a principle of databases. So it's a DBMS software. It will have databases, and databases will have tables in it. So I will consider one of the database here called reg records or registration records. If I just happen to open it, so I'll have these tables inside my reg records dataset. So what I'll try to, my motive is, let's try to take this table called regis for registrations. I have certain data in it. This is almost equivalent to the enrollment data that we go on. So I just want to import this data into R. Remember, DBMS is an independent software for all those who don't know. Yeah, most of you would be knowing it. So this contains data, and my motive is to get this data into R. So I'll just do that using MySQL. You have to figure that out for Oracle and all, because I don't have Oracle. I don't use Oracle. So let's begin with this. Here I have a package called RMySQL. This is for MySQL, right? So I'll just load this package. That's it. It contains certain things which needs to be done so that data connectivity happens. Connecting to a database has the following steps. Your first step would be establishing a connection. To establish a connection, you must have the location or remote location of the DBMS software. You must have that location or remote location of a DBMS software. You should have user privileges, user or access privileges. If you don't have it, you can't access a DBMS. DBMS is one of the most strictest softwares in this world. It can be any DBMS. It won't let you access the data as it is. So let's do that. My first step, establish connection. So yes, this is the credentials that I have. Yes, the name sounds weird, but no one can guess it, right? Password is also very strong password because no one can guess. Like a seasoned DBMS, a seasoned DBA putting password as password. No one will guess it. Seriously, no one will guess it. So I'll use the function called dbconnect to connect to my MySQL database. This is my username, this is my password. Come on, 1 second, Tanvi. Hold on. Now, a host, because I'm hosting this in the local system, I'll have localhost. Like localhost is almost equivalent to this, right? Port number, I don't know the port number. Okay, this runs on the port number called 1756 3306. Okay. So this is my local record. But if you have a remote server, you have to specify the IP address and port number. And yes, Tanvi, even if you are using any local DBMS, let's say you have installed SQL Express, Microsoft SQL Express, it will definitely give you one IP address and port number to connect to. So does Oracle, if I'm not mistaken. It will give you a location to connect to. It will give you an URL to connect to. So these are my credentials, and I'll be connecting to the DBMS database name called reg records here, right? So that's I specify that over here in this argument called dbname. So dbconnect is the function, and these are the arguments to it. This is my first stage, establishing a connection. So I'll run this entire set of statements. If it is run successfully, there are no errors being displayed, and that one more object has been created in my global environment, it means connection is successful. Had it been shown any error, then it means that my connection fails. Now, that's dbconnect. My second function is dblistTables. This is actually a helper function. This is not importing the data, but it is just trying to list out the tables present in your DBMS. So that's dblistTables. Don't worry about it. I'll anyways give this file to you. You can refer to this codes. So it gives me a list of tables that are present in my DBMS that I have connected to. So here is it. You can just match admin, cars data, course, players, regis, right? So I have all these things here shown in R. This is happening because I have a connection that has been established, without which I can't do that. Now what I'll do now is I'll pick the table called regis, registration details. So now here the things get a little bit crucial. Now things are not as direct, like you can't just say import a table. You have to run a SQL query, right? So I'll use a function called dbSendQuery. dbSendQuery will send a query to the database, right? And it will try to process something out of it. So my query here is select star from regis. What does it do? Select everything, right? Select star means select everything, isn't it? I hope you guys are following it. So I will store it in a string object called q1, and I will pass the q1 to dbSendQuery function. So this would basically send query to the DBMS, and it will create some object in my global environment. Remember, our data is not fetched yet. This will be just sending a query. This is just sending query to DBMS. We don't have the results yet. So this is send query to DBMS. Now second step is to get the results, of course, right? Fetch the output to R, for which I'll be using fetch command. I'll be using fetch command for that. So I'll say fetch R is n is equals to -1. This is the default argument. I may or may not give it. This will n is equals to -1. We'll try not to skip any row. That's the meaning of that statement here. N is equals to -1. But fetch function, the primary input to us is the RS object, the DB send query object that we had just created. Clear? So I'll pass that on to fetch statement. Now if I run this statement, it will create a data frame in my R's global environment. So DB send query will send the query to DBMS and fetch will get it as a data frame. So my step 1 is DB connect, where I will be connecting to my DBMS by specifying the driver name, which is MySQL, and specifying my user credentials and the database name. Second step is to send a query using DB send query, and third step is fetch the results to a data frame. That's it. Now DB fetch query can be used, DB send query can be used to send any kind of queries. You can also send any kind of a DML statements as well. You can manipulate the data using DB send query. So everything can be done using this. You can do stuff in R and send the data or queries back to the DBMS software. And one final thing, any R data frame can be exported to the DBMS. So let's say you have taken a table. Let's say you have done your first SAS assignment, for example. You had a car sales data set. You just try to create, you created some sample or subsets out of it based on some conditions. Let's say you have created 5 or 6 subsets and you want the subsets to be written to the database. So in that situation, what you will do is you'll take these R objects. Let's say I have something called XML data here. I will use a function called dbWriteTable. So in dbWriteTable, all I have to do is first create a table in my DBMS. I'll call this as XML data export. I'll call this table as XML data export. This is the name of the table in the database that I'm trying to create. The R objects here I'm trying to pick up. I have an R object called XML underscore data. This is the R object which I wish to send. And finally I have an argument called overwrite is equals to true. If the table exists in the DBMS, just overwrite it. So if I happen to run this statement here, I'll get true. But if I just go back to my DBMS and refresh it, I would be getting the table over here. As you can see, I have XML data export here, right? The table has been exported. You can see that here. The last one, XML data export. Clear with this? Any question, classroom guys? Online people, any questions on this? Pardon?
Need practice.
Yeah, it needs practice, yes. Yeah, just try connecting to any of the DBMS that you know. This is for MySQL. You have used R MySQL package. I have a package called RODBC for Oracle. R Oracle database connectivity. For all you Java people, I have RJDBC. If you're good at Java database connectivity, you can use RJDBC. Connecting to MS SQL is always a challenge. You have to install certain paid or licensed drivers for that, without which you can't do it. So let's not touch that. But you can just try how to export that to Oracle. The same kind of functions go in. Same kind of functions, same logic. Alright then, I hope we are done with